I guess we're going to take a look at how to solve inequalities Desmos version. So we're going to go into a new tab and you're going to Google Desmos Graphing and the state that you're in. So Desmos Graphing GA. All right, this is going to ensure that you get the calculator that's going to be for your state. So Desmos Graphing GA. All right, and then we're just simply going to follow the directions and input them into the calculator. So solving equations, it says copy and paste the entire inequality into Desmos. So here's my inequality. I'm going to go ahead and copy it in. So it says 15x is greater than or equal to 30. All right, boom. Copied it in. Number 2. The shaded part of the solution, starting where it intersects the x-axis, so this is where it intersects the x-axis, here's how you read it. If it's open, if it's less than or greater than, dotted line. Notice that doesn't have an equal to at the bottom. If it's closed, if it's less than or equal to, this line at the bottom means equal to, or greater than or equal to is a solid line. So it's open, dotted line, closed, solid line. So I can tell this is a solid line because it has that equal to. So if I actually change that to an open, do you see how it becomes a dotted? All right, so just know that open, which we've been talking about as parentheses, and closed, bracket. Okay, so open, closed. Same thing with lines. Open line, which would be like that, dashed, and then closed line would be like that. All right, so greater than or greater than equal to is shaded to the right. So you can see that because this is greater than or equal to, it's shaded to the right. Less than or less than equal to is shaded to the left. So if I change this to less than, shaded to the left, or less than or equal to, shaded to the left. That's all the notes are telling you. All right, so let me put back the original question because all I have to do is transfer the original question into my answer. So there's the first question. Solving. So the answer to this one, because it's shaded to the right, is x is greater than or equal to. And what number is x equal to? So I'm going to go to x and I'm going to say it's equal to the x value right here, which is equal to 2. So x is greater than or equal to 2. All right, type in the second one. And it doesn't matter how complicated it is. Actually, I'll do the third. Yeah, I'll do the second one. All right, 5x minus 20 is less than or equal to 30. And it says, okay, so zoom out so you can see where it is. There it is. It's shaded to the left. So, and then it's solid, right? So it's going to be, and actually, while I'm here, you can check your answer. So x is left and solid, so less than or equal to. And what's the number that I think it is? 10. X is 10, right? So I'm going to say 10. And if it overlaps, that's perfect. I forgot we could do that. All right, so if it overlaps, boom, 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 you are completely right. So the answer to this one is x is less than or equal to 10. And honestly, it doesn't matter how complicated it is. All you're going to do is just type in your answer and check it. All right, so let's go ahead and do this one. So this is 4 parentheses 2a plus 3 close parentheses greater than -3. And just the biggest thing about this is just making sure that you type it in exactly what you see. So when you finish typing it in, you can extend the line like this. You press down on your mouse. Maybe not. Maybe I need to make it bigger like this. All right, I just want to see more of that. I want to see the whole thing. Just match it. Just make sure you typed in exactly what it is. Once you're sure, okay, you're good. Now there's an error here. Why? Because it tells you. You're going to click on it and see what's the problem. We only plot inequalities of x, y, or r, and theta. Okay, cool. So we're going to go replace all of this with x. Because that's all you guys plot. That's fine. I'll put x in there. Oh, I don't like black, but okay. That's the color, right? So all of that is to the right. And notice it's dotted. Because why? There's no equal to right there. So this one, now I'm not going to put x even though it says x. It says a, okay, is on the right of what number? But we're going to check our answer with x. So x is to the right, and because it's a dotted line, make sure it's dotted. And what's the number that it's to the right of? 2, because x is 2. Boom. If it overlaps exactly, you know that you've typed that answer correctly. So a is greater than 2. And again, I'm not using x because you have to use the letters that they give you. All right, example 4. I'll do one. Actually, you know what? You do example 4 and 5. All right, so that's how you solve inequalities in Desmos calculator. Now we're going to take a look at how do I graph inequalities using Desmos. So again, copy and paste the entire inequality into Desmos. So I'll go ahead and do the first one. All right, so it is, I'm just going to move this just a tad that way. So x is greater than or equal to -7. So I can see the solid line because of the equal to, it's to the right of -7. All right, cool. Then it says transfer the graph to your answer, but getting 2 coordinates by joining them and shading. Okay, so we've talked about this before. There are 3 methods. All right, and here they are. Finding coordinates x and y that lie on the corner. Our favorite one is the table, which is gear, and then table. But remember, the table only works if it's y equals, and this is not y equals. So there's nothing we can do about that. So we cannot get a table because there's no y in here. So we cannot do that one. So it's going to be one of these 2. I'm going to zoom out so that it goes up by 1. You see how it's going up by 1. So if it goes through the x-axis, just go to it. That's going to be the easiest thing. So it says start on the far part left of the graph, follow it with your mouse until you get to a whole number. This is a whole number. Or until you get to a corner, whichever one. So this one is at -7. You can see it's a straight up and down solid line. So that's all you're going to do, a straight up and down solid line at -7. And then you're going to shade it all the way to the right. Okay, so obviously don't make sure you don't pass that because I clearly passed it. All the way shaded all the way to the right. And we're just copying the answers into our worksheet. All right, number 2, copy and paste again. So put the arrow up, copy and paste. This time it's y is greater than -7x. And notice now you have a dotted line. Now look, please do not put any answers in until you see it looks like this. It should be going like this, down, dotted, shaded to the right. Don't start copying things when they don't look like what the calculator is telling you to copy. All right, so again, we're going to try table. Option 3 is our favorite one. All right, so after typing, ooh, that's not what I meant to do. Undo. All right, so after typing this in, the equation into Desmos, well, actually, I don't know if I have to use equal to. Let's see. Click on the setting wheel. Okay, so it's telling me I do. Okay. So look, this is what we're going to do so we can cheat and get the coordinates and then put it back. It says use equal instead of the inequality. So I'm going to come to the inequality. In fact, I'm going to just do this. And instead of the inequality, I'm press equal to. Now, when I do that, I can get this table that I need. So I can press table. All right, so I have to I have to make it an equal to get the table. And here are my coordinates. So all I have to do is transfer the nice numbers that I know how to plot, like 0, 0. I can definitely put 0, 0 there. Boom. 1, those are so negative. Okay, -1, 7, -1, 7, and 1, -7. So x and then y. Boom. All right, now I'm going to get rid of this table because I don't want to get confused. This was my original inequality. Is my line going down? Yes, it is. Is it passing through 0, 0? Yes, it is. Is it passing through -1, 7? So -1, this is 5, 6, 7. Is it passing through right there? Yes, it is. Boom, you can see it is, right? So again, just double checking your answer. Now, copying it, please copy exactly. You can see that it's dotted. So please put dotted. I say dotted, but it's really dashed. Boom, dashed. And then which side is shaded? Again, just look at the graph and make sure, and I can do this to that so I can see. It's shaded on the right-hand side, so please make sure that you shade the right-hand side. Okay, so we're just following instructions and just making sure you're double checking what you're typing into the calculator. And you're also checking what you're copying from the calculator. All right, let's go ahead and put this in. So again, you're typing exactly what you see. So y plus 7x is less than or equal to 5. Boom. All right, now, big thing is I need to transfer it, right? So 3 ways of, well, actually, there are 3 ways of transferring, but sometimes you don't even have to do all that because you have good numbers. Oh, that's not a good number. So I have one good number there. So that's helpful. That's 0, 5, 0, 5. All right. So now I don't have a nice number at the bottom. So what can I do? So 3 methods. All right, here's the thing. You can only use the table after making it y equals. Now, if you know a little math from your middle school days, we can do that. So I'm going to start it on a fresh line because as long as this line matches with this, I'm good. So I'm teaching you how to make it y equals 2. We're going to start by taking this to the other side, subtracting 7x. So I just delete that. Subtract 7x. Okay, or I can put it on the other side, honestly, it doesn't matter. Okay, let me put it here. Subtract 7x. Did it change? No. So whatever I've done is good. Now I have y is less than or equal to. And remember, for me to get the table, I just need to change that to equal to. So once I change it to equal to, I can hit gear and then table, and then I've got my points. So that's one way of doing it. But let's say that you're not so comfortable with solving an inequality or solving an equation. What is the other way of doing it? Well, you can start on the left part of the line and follow it with your mouse until you get a nice whole number. Now, before I do that, what I'm going to do is I'm going to zoom in. So I'm going to hide this, and then I'm going to zoom into where it's going up by ones. Right now, it's going up by twos. I need one more. All right, boom. Now it's going up by 1. So I already know that this one is a good number right here. Why isn't it? There you go. So the thing about doing it this way, it does take a little bit of finesse. You're just going to go until you see it like kind of change over. So you see how it's decimals, decimals, decimal. Just keep a lookout to where it kind of looks like it became less than a decimal, or like a small, like there. Like I feel like there, like it became kind of smaller. Once it became kind of smaller, kind of try and get it right on it. Okay, it became smaller, but it didn't help me. All right, so even though it was smaller, it wasn't what I was looking for. So you're just going to keep going. And again, you're looking at the decimals and how they're changing. Gonna keep going, gonna keep going, gonna keep going. Yeah, that doesn't help me because that's still a fraction. Now, this is a process, as you can see. And it does take a while. You just got to be patient. So again, just keep looking at those decimals. If it looks like it got smaller, like, wait a minute, it's got smaller. There it is. So there's a point. Positive 1, negative 2. But that can be really like time consuming, right? So what you can do again is look at the boxes. So find 1. So here's 1 and there's 1. So this is a box. And what you're looking for is when is this line going through this box? So it's not going through any of these corners. So corners are top left, top right, bottom left. So if I draw an imaginary box here, it's not going through a corner there. If I draw an imaginary box here, it looks like this is a corner, and I can bring my mouse right there, and that would be faster than me just randomly looking for it. So I do have a point at 1, negative 2 that I can transfer over. 1, negative 2, and all I need is 2 points to make this solid line. So make sure you're copying it correctly, solid line, and then shade the left-hand side. So if the solving the equation is not going to work for you, it's really fast if you just look for, the box. Just the box needs to be 1, 1. The unit is 1, 1. So you need to determine how big the box you're looking at. Not these little boxes, but where 1 and 1 is. That tells you the box that you're going to draw. Right, the other thing that we need to talk about is whether a coordinate pair is a solution to the inequality. So for it to be a solution, we're going to copy this down. So solution is in the shaded area. Stay away from dotted lines as they are open. So remember, right? So a dotted line is a parenthesis, right? Which means does not include. A shaded line or a shaded area does include, so those can be solutions. All right, so we're going to write down some solutions for example 1, and you're just going to write it on the side. So your question is, and then we're just going to give it a coordinate. Let's say 5, 2. Is 5, 2 a solution? So you're going to go to where 5, 2 is. Okay, so 5x and then y. Is this a solution? The question you're asking yourself is, a solution is in the shaded area. Stay away from dotted lines as they are open. So is this in a shaded area? Yes, it is. So you're going to say yes. Okay, so I'm going to give you a few examples just to make sure that you're okay. All right, so let's ask another question. So you're going to copy the question down because I definitely forgot to put it in your notes. So on example 3 is 1 negative 2 a solution? And you have to be prepared to explain why, right? Is 1 negative 2 a solution? So again, you're going to go to x and then y, 1 negative 2. It is on this line. So the question being is, solution is in the shaded area, stay away from dotted lines as they are open. So what about solid lines? Can I be on a solid line? Yes, because a solid line is closed, which means it includes it. So yes, because this is a solid line, so it includes that. So anything here, here, anything here, and over here, those are all solutions. All right, let's do another one. Again, just add this to your notes. Is, let's say, -1, -5 a solution? So again, go and look at where -1 and -5 is. So we're going to look at -1, -5. That's over here. Is that a solution? Well, let's look at our definition. So a solution is in the shaded area. Stay away from dotted line as they are open. Is that a solution? No, it's not anywhere on the shaded. So this is going to be no. Okay, we're going to add one more question to this one. What about, let's do 0, 0. Is 0, 0 a solution? So again, add that to your notes. Is 0, 0 a solution? So you're going to go plot a point at 0, 0. Okay, now that is exactly on a dotted line. So remember, okay, solution is in the shaded area. Stay away from dotted lines as they are open, which means they don't include it, right? So even though this is on the line, it's on the dotted line. It does not include it. So is this a solution? No. All right, so that's going to be a very big question they ask you, and they love putting it on the lines just to make sure that you understand the difference between open and closed. So open does not include, closed includes. Okay, so that's how you find what a solution is. All right, so you're going to go ahead and do this last question, and that's how you graph and solve linear inequalities. Let's practice.